If you look at the game of hockey in general, concussions are part of it because it's a fast sport. You lose an edge or bumped into boards, you go into a post, helmet on helmet contact. There's just so much that can happen.
Concussion is the result of an impact to the head or also elsewhere to the body. Since the human brain is very heavy, it actually can lead to small injuries in the tissue and to changes in brain function that usually go away, but sometimes they can also be quite persistent and last for several weeks or months even.
At UBC, we just started this 5-year collaborative study with the UBC Thunderbirds men's and women's hockey teams. And there are 2 main research goals here. One is to study the brain changes after sports concussions, and the other one is to study how repeated impacts might lead to longer-term brain changes. We're going to use these special mouthguards that contain sensors to measure impacts that hockey players sustain in their sport. And these sensors are found in previous research to be more accurate than other sensor types, such as helmet sensors, because they sit very close to the skull. And we're combining these sensors with other types of testing to better understand outcomes after concussions.
Research suggests that women are more likely to sustain a concussion than men, but the majority of the research has been performed on male populations. And with this study, as we're looking into reasons why is that the case, and what other factors contribute to that increased risk. We're also looking at the effects of those accumulation of head impacts on neurocognitive function. So we're looking at their memory, their moods, their focus, how it affects their balance, and also vision.
Each player is equipped with their own special mouthguard that comes with an IMG sensor attached inside of it. Data comes into the iPad in real time from the ice and from the players wearing the mouthguards on the ice. So anytime there's an impact, the mouthguard will transfer data via Bluetooth to the iPad, telling me the linear velocity, the angular velocity, the region of the head that the impact occurred in, as well as how many G's of force the impact was. And I can go back and look at the video data and validate whether this impact actually did occur on the ice.
In young players, especially in athletes who are at university or in high school, the consequences of a concussion might happen during final exams and such things. The memory problems and the lack of ability to focus just on studying can have, of course, negative consequences on the academic performance.
For us here at UBC, it's very different because you got to remember these guys have midterms and exams and they can't miss anything because they'll fall behind real quick with such a demanding load with the academics.
We are hoping to really dig into how the forces of impacts might lead to different outcomes in concussions and better understand this injury. And with this understanding, we can also potentially start to develop better preventative measures such as helmets, as well as diagnostic testing.
Ultimately, we hope to learn how long it takes the brain to recover from a concussion and also give athletes information on where they should take a break after they had a certain number of hits so they do not have the risk of ending up with long-lasting negative effects from concussions and hits.